Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we will study the architecture or the block diagram of the 8086 microprocessor. We will also study the detailed functions of every block of the 8086 microprocessor. So let us start with our topic. The architecture, or we can say the block diagram of the 8086 microprocessor, it is divided into two main blocks. First is the bus interface unit and second is the execution unit. The bus interface unit, this block, it performs all the operations of the bus which are associated with the bus, like instruction fetching and then reading and writing the operands and then providing the addresses or calculating the addresses for the memory and the input output devices. So all the operations which are related with the bus of the 8086 microprocessor, that are performed by the bus interface unit, while the execution unit, it executes the instructions which are written in the instruction queue. Okay, so if we talk about the functions, bus interface unit, so bus interface unit, that is BIU, it performs all the operations which are related to the system buses like the address bus, data bus and the control bus, and the operations like instruction fetching and reading and writing operands into the memory and calculating the addresses of the memory operands. So all these functions are performed by the bus interface unit. Second, we have the execution unit, which executes all the instructions. So from the instruction system byte queue, the execution unit is going to extract all the instructions and then it is going to execute those instructions. So that is the function performed by the bus interface unit and the execution unit. Now in these two units we have various blocks. So let us see the block diagram or the architecture of the 8086 microprocessor. This is the block diagram in which we have the two blocks. The upper part, it is the bus interface unit BIU and the lower part, it is the execution unit EU. So in the bus interface unit we have the instruction queue here, in which the 6 instruction bytes they are stored, because the 8086 it has a facility to prefetch 6 instructions at a time. So for those 6 instructions they are stored in the instruction stream byte queue. Okay. Then we have the segment registers, the extra segment, code segment, stack segment and the data segment registers. So these 4 are the segment registers. Then we have the instruction pointer IP. Then we have the address adder. This is the address adder. and here we have the memory interface. So this unit, it is going to be connected to the address and the data bus. Okay, so in the bus interface unit, we have the instruction queue, we have the segment register, instruction pointer, and the address adder. Whereas in the execution unit, we have the control circuitry here, the control system. So this is the control circuitry. Then we have the instruction decoder. Okay, then we have the stack pointer, base pointer means the pointer register, and the index registers. Then we have the general purpose registers also. These are the general purpose registers. The accumulator, the base register, code register, and count register, and the destination register or the data register. Okay, then we have source index, destination index, base pointer, and the stack pointer here. Then we have the arithmetic logical unit, ALU, also here in this. We have the operands and the flag register also. So in the execution unit, we have the registers and the control circuitry. And this execution unit, it executes all the instructions which are there in the instruction queue. Okay, so this is the these are the blocks which comprises the bus interface unit and the execution unit. Now let us study that what are the functions which are performed by the bus interface unit and the execution unit. Now both these units, the BIU and the execution unit, they means they work asynchronously with each other. That means that the functions of the bus interface unit, they are independent of the execution unit. Okay, bus interface unit, it is going to provide the instruction bytes, and those instruction bytes will be executed by the execution unit. So we can say that both units So both these units, bus interface unit and the execution unit, they operate asynchronously. Asynchronously means that the function of the bus interface unit, they are independent, they does not depend upon the execution unit, and also the function of execution unit, they are not synchronized or they are not occurring at the same time of the bus interface units. So both operate independently of each other. So bus interface unit, it is exactly what it is doing. It is fetching the instructions code, and those instructions are executed in the execution unit. So fetching is done by the bus interface unit and execution is done by the execution unit. So if these units, they are operating asynchronously, means that the fetching and the execution of instructions, it is done at the same time. Okay, so this feature, this asynchronous work of both the units, it gives the 8086 an overlapping mechanism, means in fetching and execution of the instruction, it is done at the same time, and that is known as the pipelining. So this pipelining means that while the first instruction, it is being executed, the other instruction is at the same time, it is fetched. So fetching of an instruction when a current instruction is being executed, that is known as pipelining. So fetching the next instruction while the current instruction executes is called pipelining. Okay, so it reduces the time taken to execute or to execute a whole program. Okay, because when a current instruction is being executed, the next instruction is already being fetched, so the time taken to fetch the next instruction has been reduced. Okay, so this feature is known as the pipelining feature, and this pipelining, it results in efficient use of the system bus, and it also improves the performance of the system. Okay, so this is an additional feature in the 8086 microprocessor, because it has the bus interface unit and execution unit which are operating asynchronously. So the fetching and the execution, they are independent of each other. So while the current instruction it is being executed, the next instruction has already been fetched. So now let us study that how this 8086 microprocessor works, and the blocks, bus interface unit and execution unit, what are the functions performed by them. Okay, first we will start with the bus interface unit. Now, as I have said that the bus interface unit, it performs all the bus operations. So we can say that this is responsible for all the external bus operations like instruction fetching and providing the operands and calculating the memory addresses also. So all these operations, they are performed by the BIU. So this BIU unit, it consists of the 16-bit bidirectional data bus and the 20-bit address bus also. So this bus interface unit, it is responsible for all the external bus operations. Like we have the 5 functions performed by BIU. First is the instruction fetch, second is instruction queuing, then third is the operand fetch and the storage, then address relocation and the bus control. So all these 5 operations, they are performed by the bus interface unit using the 16-bit data bus, address bus and the address adder and the instruction queue. Okay. So this bus interface unit, its second function is the instruction queuing. First is the instruction fetch. So it is going to fetch the instructions which are written in the memory. Okay, so from memory it is going to fetch all the instructions. Then those instructions will be queued in a line, means it is going to use a mechanism which is known as the instruction stream queue to implement the pipeline architecture. In this instruction stream queue, queue, 6 instructions are prefetched, and these 6 instructions will be stored in a memory, and this memory it follows the LIFO, that is last in first out. That is the first element that will be inputted into the memory, that will be the first to get out of the memory, that is last in first out. So this 6 instructions, they will form a queue, and those instructions will be executed according to their sequence. So this instruction queue, it permits the prefetch of up to 6 bytes of instruction code, and when these 6 bytes, this instruction queue it is full, then the execution unit it is going to execute the instructions according to their sequence. So these instructions, they are held in its FIFO queue. FIFO means first in first out, means the first instruction that will be stored in the queue, that first instruction will be executed first. Okay, so this queue, it forms the first in first out, it follows this format, first in first out. Now this bus interface unit, it has a 16-bit data bus. So with the help of this 16-bit data bus, the BIU, it fetches 2 instruction bytes in a single memory cycle. Now when this memory read operation is performed, it is going to read the instructions which are written in the memory. So this BIU unit, it is going to fetch 2 instructions in one single memory cycle. Okay, so 2 instruction bytes are available to this BIU. Now when a byte is loaded at the input end of the queue, it automatically shifts up so that the next instruction can be stored in the FIFO memory. So in this way, one after the other, 6 instructions can be stored in this stream queue, instruction stream queue. So in the instruction queue, first byte of the instruction will be stored, because 2 instruction bytes are fetched by the BIU unit. So in this, if we have, this is the memory. So first and second instruction bytes will be stored in one memory cycle. In next memory cycle, we have the third and the fourth, and in next memory cycle, we have fifth and the sixth. So in this way, the first element, it goes at the bottom of the memory, and when the execution unit, it reads the first unit, and then it is going to execute it. So execution unit, it accesses the queue from the output end. It is going to execute the first instruction. Now when this first is executed, these instructions will be shifted down, and again there is a space for the next instruction to be stored here. So it reads one instruction byte after the other from the output of the queue, and when this is executed, all the instructions, they shift down, and there will be a space for one more instruction. Now, when the execution unit, it has executed all the instructions, so now the queue is empty, there is no function to be performed. So intervals of no bus activity which may occur between the bus cycles, they are known as the idle state. Okay, when the buses are not involved, when there is no bus activity involved, so that interval of time, it is known as the idle state, because the microprocessor, it is not performing any function at that time. Okay, so that state is known as the idle state. So if the bus interface unit, it is already in the process of fetching an instruction, means BIU is fetching an instruction, and at the same time the execution unit, it requests it to read or write the operands from the memory or the input output devices. So what this BIU is going to do, it is going to first complete the instruction fetch bus cycle before initiating the operand read and write cycle. So first the BIU unit, it is going to finish the instruction fetch cycle, and then it is going to perform the operand read and write cycle. Okay. So the bus interface unit, it also contains a block which is known as the address adder. This address adder, it is used to generate the 20-bit physical address, because it has a 20-bit address lines. So the address of the memory location will be of 20-bit. So this address is generated by the address adder, and this address, it is output on the address bus, so that address will be available on the address bus. Now how this 20-bit physical address will be generated, this address is formed by adding an appended 16-bit segment address and a 16-bit offset address. So first we will have a 16-bit segment address, and then we will have a 16-bit offset address. For example, the physical address of the next instruction which is to be fetched, it is formed by combining the So the next instruction which is going to be executed by the execution unit, the address of that next instruction will be generated by combining the current contents of the code segment, because code segment, it contains the, it holds the address, the starting address where the instructions are written. Okay, so starting address will be provided by the code segment contents and the current contents of the instruction pointer, because instruction pointer, it points to the memory location where the next instruction is written. So first we will have a 16-bit segment address which will show that the operand or the data it is present in which segment, either code segment, stack segment, data segment, or extra segment. Okay, so it is going to give us the location of the segment, and then the offset address will provide the exact location of that instruction. Okay, so the next instruction which is to be executed, that physical address will be generated by combining the contents of the code segment and the instruction pointer. So in this way, the address adder, it generates the 20-bit physical address. So this bus interface unit, it is also responsible for generating the control signals for the memory and the input output operations like memory read, memory write, input output read, input output write. So those control signals are also generated by this BIU. So if we see the block diagram of this 8086 microprocessor, so in this block diagram we have seen that this bus interface unit, it is having the segment registers. So the address of these segment registers plus the address from the instruction pointer, that will be combined by this address adder, and this address adder is going to provide the 20-bit address on the address bus. Also, this has this instruction stream byte queue where the instruction code for 6 instructions are stored, and these instructions will be then executed by the execution unit. Also, this bus interface unit, it provides the control signals. So those control signals will be given to the control circuitry so that the memory read or memory write and input output read and write operations can be performed. So that is the functions which are performed by the bus interface unit. Now let us come to the execution unit. As the execution unit, it performs the function of executing the instructions. So instructions are fetched by the BIU unit. Those instructions are then decoded and then they will be executed by the execution unit. So here we can say that the execution unit, it is responsible for decoding and executing the instructions. So this execution unit, it is going to extract the instructions from the queue. The first instruction will be extracted, then it will be decoded, and then it will be executed by this unit. So EU extracts instructions from the top of the queue, then decodes them, generate the operands, so this execution unit, it is going to first extract the instruction from the queue, then it is going to decode that instruction. Now if that instruction, it involves any operand, then it is going to generate the operands, and then these operands will be passed to the bus interface unit. The bus interface unit is going to be then given a request that either perform the memory read, memory write, or input output read or input output write operations. So if operands are involved, then those operands will be operated by the bus interface unit, and then the operation will be performed which is specified by the instructions. So suppose we have an add instruction, and add instruction involves the addition of the register and a number. Okay, so this addition instruction, it is first that opcode will be fetched from the queue, then opcode will be decoded. Microprocessor will get to know that the addition operation it has to perform. Now this addition, it involves two operands, the register and the number. So the register, the number which is stored in the register, it has to take it from the bus interface unit. Bus interface unit is going to provide it the data. Then the operation, that is the addition of the two numbers, will be performed by the execution unit. So in this way, the execution unit, it decodes and executes all the instructions which are present in the queue. Now when the instructions they are executed by the execution unit, the status and the control flags, they are also checked by this unit. So this execution unit, it is going to test the status and the control flags. Means it is going to check the status and control flag, and depending upon the result of the operations, it is going to update these flags. Now suppose if the execution unit, it extracts the instructions from the instruction queue. Now if the queue is empty, then this execution unit, it is going to wait for some time, that when the next instruction byte will be stored in the queue, then it is going to fetch that instruction byte. Okay, so if queue is empty, execution unit waits for next instruction byte to be fetched and shifted to top of the queue. Okay, so when the 6 instruction bytes they will be stored in the queue, then the execution unit, it is going to fetch the instruction and then it is going to execute it. Now suppose that the execution unit, it is executing a branch or the jump instructions. So in these instructions, what it happens that the program, it is going to jump to some other location, and then the instructions which are written at the different location, those instructions will be executed. So in that case, the control of the program, it is transferred to a different memory location. So the address of the next instruction, that is stored in the stack, and the programmer, it jumps to different location, and at that location the instructions will be executed. So the execution unit, it also shifts the instruction queue from this location to the new location. Okay, so when the execution unit, it executes So in this case, what the bus interface unit it is going to do, it is going to reset the queue, and the instructions which are written at the other memory locations, those addresses will be queued in the instruction queue. Okay, those instructions will be queued in the instruction system queue. So BIU automatically reset the queue . So when branch or the jump instructions are executed, then bus interface unit, it is going to automatically reset the queue, and then it is going to begin to fetch the instruction from the new location, okay, where the branch or where the subroutine is written. So this is how the bus interface unit and the execution unit, it performs the various functions. In the block diagram, we have studied that the bus interface unit, it comprises of the segment registers, the address adder, and the instruction system queue, and also the 16-bit data bus and the 20-bit address bus. Whereas the execution unit, it has the flag register, which contains all the flags like status flag and the control flags, and also the instruction decoder is there, instruction pointer, control signals, control circuitry is also there in the execution unit. So I hope that so in this video we studied about the architecture and the block diagram of the 8086 microprocessor. So I hope that this video is clear to you. Thank you.